Welcome back to chapter 2. In this chapter, we're going to be looking at graphs and equations of lines. This may be something that some of you have already seen, or it may be brand new to some of you. So we're going to go over it like it's new. Um, and there's a lot of good stuff in this chapter. It's split into 4 sections. The first 3 sections are going to be on different forms of lines. The first one's slope-intercept form, then the second one will be point-slope form, the third one is standard form. In the fourth section, we'll look at parallel and perpendicular lines. So all 4 of these sections are very closely related. It will use some of the skills that we learned last chapter on solving equations. Not so much today. There's a little bit of that today, but not a ton. But it's using it in context and not just like, hey, solve the equation because you have to solve the equation. We're specifically looking for equations of lines. So today we're going to be looking at the slope-intercept form of a line. Our learning targets is we can write and graph linear functions using the slope-intercept form. And so, next question is, what is slope-intercept form? The slope-intercept form of a line it comes in the equation y equals mx plus b. Now you've probably seen this equation before. It's the one that we generally think of when we think of graphing a line. X and y, these are our points. They're the points on the line, and points, when we graph them, go x comma y. The m is what's called the slope. We'll be seeing more about the slope here in a second. And b is the y-intercept. So that's where it crosses the y-axis. So what is the slope? Now the slope has a bunch of different types of definitions. The slope is a steepness. It's how steep is the line. A slope is a rate of change. The key word in that is rate. So if we're dealing with a word problem, if something costs $6 per hour, that 6 is the slope. That's the rate of change. It's the rate of change of the cost. It could be the speed of a car is a rate of change. If you're dealing with a word problem and you have something that has a unit of something per something, that's probably going to be your slope. So it's a steepness. It's the rate of change. A lot of times we think of it, it's the rise over the run, which the rise is going to be the change in y, and the run is the change in x. We have a symbol that means change in. It's a capital delta. It's a Greek letter. You'll probably see it in your science classes at some point in the near future if you have not already done so. But that just means change. It's a change in y over the change of x. Or it's y minus y over x minus x. I know the book and probably everywhere says y2 minus y1 over x2 minus x1. Yes, that's what it is. Which is point 1, which is point 2, it doesn't matter. As long as one of your points is right here and one of your points is right here. And we're going to see some examples of this in just a minute. So it's a steepness, the rate of change, rise over run, change of y or change of x. The pitch, like the pitch of a roof, is going to be the slope. It's the angle of the line. And so all of those things are ways that we can think of slope. And what's the y-intercept? The y-intercept is the y value when x equals 0. So it's going to go through the point 0, comma, b, because the y-intercept is b. In a word problem, this could be a starting amount. Starting value. A lot of times in word problems, we'll have something that costs a flat fee of, say, $5. and then and $6 per hour. And so the flat fee is the y-intercept, and the $6 per hour is the rate or the slope. And so that's where we see stuff like that. I know I had some plumbing that had to get done last winter. I had a couple pipes not do so well in the cold, and so I had to call a plumber, and they cost like $60 an hour for them to be working on it, but it cost me $40 just for them to drive out to my house. And so when they worked for an hour, it was the 40 plus the 60, which was $100. If they worked for 2 hours, it was the 40 plus two 60s, which was $160. But that 40 is there and it doesn't change. So that's the idea of the slope and the y-intercept. Now the y-intercept, we're going to see how to find that. I mean, if you have a graph, you just look at the graph and you can see it. If you don't have a graph, we'll see how to find it. But it's generally pretty easy. The slope, though, is what we need to start with. Oh, and notice when we have the equation of a line, something that we'll see is consistent is we have a starting point and we have a direction. The starting point is going to be the y-intercept in this case, and the direction is the slope. So let's find the slope. The slope we can find it using different things. If we have a graph, rise over run is usually how we look at this. So we go up this amount, and so we're going from a y is 3 up to a y is 6, so it's going to be 3. It's a little bit confusing in my graph because each mark is actually 2. So we're going up 3, so the slope is going to be 3, that's the rise, over, and then how much do we go over? So we're going from here, we're going all the way over to here. So from 0 to 5, we can actually count this out if we wanted to. That's 1, 2, 3, 4, 5. So we have 3 over 5. Our slope is 3/5. So given a graph, we can look at it and we can like count the boxes basically. Look at the rise, look at the run, and that was 5. And you can make a drawing like this to help you out, especially if it's a tougher type problem. Here we had 2 points that were given to us, and so those 2 points they're nice and easy to use. If we didn't have 2 points, we would want to find points where it crosses at nice places. For instance, we could have used that point right there because it crosses at a nice place where we could figure out what this point is. It happens to be 2.5 comma 4.5. So it's not quite as nice as the 5 comma 6 that we used, but we could have used it. So just anywhere where you can see it crossing a decent place is a good place to use. So that's if we have a graph, we can find the slope. What if we don't have a graph? What if we're just given a couple points? We can still find the slope. Yes, you could actually graph it if you really wanted to, but that is not the most time efficient way of doing this. And then you'd have to really graph it accurately. But remember, one of the equations for slope is y minus y over x minus x. And so we can plug it in. So remember, the y values are the second ones. We just need to choose which point is first and which point is second. It does not matter which one we choose. Let's choose, I like the 7 minus 5. So let's choose this is 0.1, this is 0.2. So slope is going to be 7 minus 5 over, and now the x's have to be in the same order. Since we went 7 minus 5, we're going to need -1 minus 2. So 7 minus 5 is 2 over -1 minus 2 is -3. So our slope is 2 over negative 3, which could also be written as negative 2 over 3 or negative 2/3. All of these fractions mean exactly the same thing. What does a negative slope mean? It means instead of the line going up like this one is, it means that the line will just have a downward. We're going to go down 2 over 3 instead of up 2 over 3. Or maybe we go up 2 and then backwards 3. It does not matter which of those values is negative, it'll still get us the right place. But right now we're just finding the slope. The slope, we have the slope there was negative 2/3. It's y minus y over x minus x. The big mistakes that people make on these, by the way, is flipping it. So you get the x's over the y's. That's one of the common things that people do. So it's something you want to be careful of. And then just making mistakes with your negatives. Making sure that we didn't go like -1 minus 2 is -1 or something like that. So it's when those negatives get involved. We have to make sure we do that subtraction correctly. So you're going to find the slope of 1. So you're going to try this one. We have the point 4 comma 2 and 6 comma negative 3. Make sure it's y minus y over x minus x, but go ahead, pause the video, find the slope, and come back in a minute when you get that. Did you get it? All right, let's check really quick. So our slope is, which way did you go? We'll go -3 minus 2 over, and then we have to go 6 minus 4. You could have gone 2 minus -3 over 4 minus 6. It'll get you the exact same thing. Simplify this. -3 minus 2 is -5 over 6 minus 4 is 2. So we have -5 over 2. If you went the other way on your points, you would get 5 over -2, which, as we discussed right up there, is the exact same thing. So we have -5/2 is the slope. Is that what you got? If not, did you get 2 over 5 or -2/5? That means you did the x's over the y's. Remember, it's y's over x's. So, writing equations in slope-intercept form now. So we found the slope. That's the hardest part of this. Now, writing equations in slope-intercept form. This one, we found the slope. M was, we went up 3 and over 5, so it was 3/5. So in slope-intercept form, which is y equals mx plus b, we have y equals 3/5 x. The y and the x stay in the equation. There are variables. And then plus, what's the y-intercept here? The y-intercept is when x equals 0. It's when it crosses this line, which is going to be 3. So y equals 3/5 x plus 3. That's it. That's finding the equation slope-intercept form. Once we find the slope, we just need to plug in the y-intercept. And you may be wondering why the variable for slope is m. Well, I can tell you. Nobody really knows. There's a few theories out there, but they've all kind of been disproven. So yeah, no one knows why it's m, but it is. It's a constant thing too. It's always m. All right, what if we have just 2 points? So we found the slope here a minute ago on the last slide. The slope was -2/3 because we went up 2 and backwards 3. So we can plug it in. We'll have y equals -2/3 x plus b. We don't know what that number is yet, but that's okay. We're going to find the number. We are going to pick one of our 2 points. It does not matter which one. Use the easier one. I'm going to use 2, 5 because it doesn't have a negative in it. And so that's just one less thing to cause us to make a mistake. We could use the other one. It will be the same. But we're going to plug these in for x and y. So we'll have something equals -2/3 times something plus b. And we plug in, let's see, y was 5, x is 2, and now we can do the math here. We have, this is still 5 equals negative 2/3 times 2. Remember, this is 2 over 1 when we multiply fractions just straight across. So that's negative 2 times 2 is negative 4 over 3 plus b. Now we're going to add it to the other side, plus 4/3. This is where the solving equations comes in, plus 4/3. And so we get 5 and 4/3, but 4/3 is 1 and 1/3. So this would be 6 and 1/3 equals b. Or you could make 5 into 15/3. And so 15/3 plus 4/3 is 19/3. That's an answer too. And now the trick from here is this is not the answer. We need to plug it back in to here. So it's y equals negative 2/3 x plus 6 and 1/3, or 19/3, depending on how you wanted to do that one. Improper fraction or mixed number does not matter. However, like 5 and 4/3, you don't want to go there. You don't want to combine improper fractions into mixed numbers. That's just bad form. So for when we have to find b, we plug it in. We plug in the slope, and we plug in one of our points for x and y to figure out what b is. We just solve for b, and then make sure you remember to plug it back in. That's one of the big mistakes people make in this step, is they forget to plug b back in. They do all the work, and they get b equals 6 and 1/3. Yes, I'm done. No, plug it back in. The question is asking for the equation of the line. And so that's right here. So try it with the one you guys found, right? You probably still have your slope from your work when you were working a minute ago. So use your slope, plug it in, see if you can find the equation of the line. The points were 4, 2, and 6, negative 3. So go ahead, try it out. Pause your video, come back when you're ready. How did you do? Did you get an answer? I think this one comes out to be a nice number too, not like 6 and 1/3. So let's try it. We had our slope was negative 5/2. So we can plug that in. Y equals negative 5/2 x plus some unknown b. Plug in x and y. This 4, 2 point looks nicer, doesn't have a negative, and the numbers are a bit smaller. So we'll get 4 equals negative 5/2 times 2. Nope, wrong way. 2 equals negative 5/2 times 4 plus b. How many of you guys made that mistake? That's another common one because the points x comma y, and then it gets plugged in with y equals something with x, and so you have to flip that order. So we get 2 equals negative 5/2 times 4 plus b. When we multiply the 5/2 and 4, we get negative 20 over 2, or negative 10, plus b. We can add the 10. So we get 12 equals b, which is not the answer, has to go back up into there. So we get y equals negative 5/2 x plus 12. How'd you do on that one? These are the big things that you're doing today as far as finding the equations. It's writing the equations from the graph, writing the equations from 2 points. Now from the graph, notice we could have just taken the 2 points off the graph and done exactly this. The other thing, so that's writing the equations. The other piece is graphing the equations. So how do we graph an equation from slope-intercept form? Well, remember, every line has a point and a slope. It has a starting place and a direction. We need to start with the starting point. So in this case, our starting point is our y-intercept. It's negative 2. So we're going to go to negative 2. And again, my thing, it's 1, 2, 3, 4, 5. It's kind of irritating because it has 2 boxes. So there we go. So we're going to start with -2. And now we have a slope. The slope is 1/2. That's rise over run. We're going to go up 1 over 2. Up 1 over 2. So we're going to plot a couple points. Up 1 from our starting point over 2. Now we can go up another one over 2. We can go up another one over 2. How many points do you need to plot? 2 points makes a line. I always plot at least a third point because that's going to hopefully catch a mistake if you did something horrible finding the first one. And then, I mean, any more points than that is just going to help you draw your line. So we went up 1 over 2. We could also go down 1 backwards 2 because 1/2 is the same as -1 over -2. The negative divided by a negative makes a positive. So we could go down 1, backwards 2, down 1, backwards 2. This comes in handy when you're kind of at the edge of a graph and so you can't go the way you'd want to go. You can always go the other way. And now we're going to connect these with a straight line because we're graphing a line. Let's see how straight of a line I can make it. No, that's not too bad. Arrows on both ends ideally because the line does stretch on in both directions. So that's where we have it. We start with our y-intercept and then we use our slope to find a few more points. Let's do another one. We have y equals -3x plus 1. So we're going to start with our y-intercept, which is 1. And now our slope is -3. But slopes are supposed to be a fraction. What's -3? We can write this as a fraction. This is -3 over 1. So rise over run. We're going to go down 3. 1, 2, 3 over 1. Make a point. We can go down 3 again. Over 1. We could go up 3 and backwards 1 as well. Connect our dots using a straight line. Arrows on both ends because it goes both directions. And there we go. All right, so how about you guys try one? Y equals -1/3 x plus 5. All right, so go ahead, pause this, try your hand at graphing, and then restart when you're ready. How'd you do? Did you get that it has a negative slope? That's the first key. All right, well, let's try. So our y-intercept is 5. Then we're going to go down 1 over 3. Let's see, 1, 2, 3. And down 1 over 3. We can draw a line, arrows on both ends, and there you go. Is that what your graph looks like? Notice this one is less steep than when we had just -3 in the second one. That one was definitely steeper than this one. The bigger the slope gets, the steeper it gets. When it's a slope of 0, it's actually a horizontal line. It's flat. So this is how you can graph from slope-intercept form. We have writing equations in slope-intercept form. That's what section 1 is about. So I will catch you in class, but until then, keep working problems, keep asking questions, and as always, happy mathing.